Excellent. Hi. I'm Sascha Kunze. I work for Mark Roberts Motion Control. I don't know who of you guys knows the company. Anybody here heard of us? Thank you. Anybody heard of Mr. Moko? Anybody heard of Showbolt or actually, this is a good one. Have you ever seen red carpet events where there's a robot going around, all your favorite celebrities doing the high speed motion? That's us. So we have taken that same technology that we use in film and commercial production and applied it to live broadcasts and studio technology. So on our screen, you can see one of the robots, which is a huge 9-axis robot that's typically associated with industrial manufacturing. We take those in and we adapt them for live studio applications to enable studios to automate some of their intro shots, use them with VR and automated graphics, and basically increase the production level that they have in a studio and freeing up resources to do more creative virtual productions, to do things like teleportation, which we'll get back to a bit later, to allow remote operation from a centralized control room, and basically allow that flexibility for studios. So as a company, we've been operating since the 60s. We've worked on the original Star Wars, did the motion control of the TIE fighters flying across the Death Star, and have grown up in that industry ever since. And today, we work in live productions and studios. We work with a lot of videographers for TV commercials, for shorts, movie productions from Fast and the Furious, Harry Potter, Game of Thrones, and all of that. We work in the corporate AV space. We work in houses of worship. We have heads that are being used for YouTubers and live streamers. So we really cover that whole gamut of automation and robotics. We also work, and this is probably quite interesting to some of the people here, in sports, where we enable remote applications and controlling of cameras in stadium from remote venues. For example, during the Olympics, after the pandemic, I was sitting in my bedroom in England, controlling robots that were in the field in Beijing and in Tokyo. So that's easily done because all our systems are based on IP control, and that same applies to studios. We have in America we have customers that are based in New York, and they control cameras in 27 stadiums around the country from a centralized location. It's not necessarily going to be the camera that follows the ball or the action, because sometimes you do need to have that emotion on there. But some of those angles, those wider shots or presets to go and cover an opening ceremony or a celebration, those can all be done remotely, and you're just giving that flexibility. All right. So I often get asked, okay, what are you trying to replace operators? No, we're not. Anybody that's studied broadcast or media or AV at school or in university, you've learned more than just moving a camera. You've learned about production flows, workflows, integration, video format conversion, set design, rundown scripting, etc. So we give that ability to the operators to still operate and control the shots and be creatively input, give the consistency and the actual motion of the cameras over to the robot, and that way you can do more with the studio with the same amount of resources. Or, in the case of many companies, we're very environmentally conscious. It reduces the travel that is necessary for most people to fly across the world to do a camera that can be done remotely, and it just allows us to be a little bit more green in our thinking and do things remotely. One use case, for example, is if you have race courses, you have some cameras that can be done, that follow the horses around the track, can be done remotely. So one operator could, for example, log into race course A in the morning, in the mid-afternoon go to race course B, and race course C in the afternoon, allowing that more of that flexibility. The same happens in countries where you have very few skilled cameramen. Scottish League, for example, they're always struggling to get camera people to come up there, stand in the rain, and do some of the Scottish Premier League matches. So that's something that can be done remotely and centralized now. Again, it doesn't change the number of people working on the job, it just gives you better working conditions, etc. So how does it all work? The remote aspect, I think, is the key. The increased creativity is fundamental to robotics because it does allow you that exact precision. Was visiting Doc 10 a few weeks ago, and they have a green screen studio here for the BBC that does BBC Sport. And again, they have intro shots that are always the same, exactly scripted. You get that lovely pull out on the virtual sets, etc. Shots that are very, very difficult to keep consistent on a day-to-day basis. Okay. So let me talk you through some of those applications. We opt for a system. Because once you've got robotics and you can do it remotely, the head's controlled over IP, we then add a layer of automation as well. So that allows the camera to actually respond to things that are happening on the pitch in real time. And in the Bundesliga, which you can see here on the right-hand side, we have a camera called the StarCam. And that's using the tracking data that's available in the football, in the stadium, to allow us to follow specific individual players for the entirety of the match at close framing. And that's something that, as good as cameramen are, just isn't humanly possible. That level of concentration for 90 minutes, the quickness of reaction that happens when you have to follow Haaland, which is where this camera was conceptualized, that type of shot is just impossible for somebody to do for the full 90 or even 120 minutes in a match. The same is the really wide shots. And I say this as nicely as possible. It's the most boring camera in football, but to the teams, it's one of the most valuable. It's to see the tactical feed. It's to see the formations, to see the lines, to see where players are playing. The tracking data exists in stadiums, and for the Bundesliga, we are offering that as an automated feed. So we know where the players are on the pitch, and using that information, we coordinate that into robotic movement. So the camera just really gently follows all 20 players and keeps them in play and keeps them in vision at all times. And that's where automation adds a little bit of value on top of just having the remote operations. And as a company, we manufacture heads, or robotic heads, that offer all types of motion. So we do everything from rail systems that give you lateral motion, lift columns, which we also have our booth at the back, that elevate and help you adjust to presenter heights, for example, in the studio. So if you have a news shot, you want your camera to be eye level. If you have somebody that comes in and is particularly tall, suddenly you need to adjust your camera, or you have a weird angle. Just press a button, camera moves up and adjusts to their height. And you can do that live on air by just really gently raising the camera up. And it really depends on what the requirements are of the production, but if the camera needs to move, we can do it. We do manufacture a PTZ camera, which is our ARC 360. This one here, that's a ruggedized, weatherproof camera that can be used in permanently installed outdoors. It's got a wiper on it, so it can withstand the sun, it can withstand the rain. It's been used in Scotland recently, where it rains a lot, I heard. So there we can mount any type of camera straight up to even big box lenses, like you saw earlier in the football application. So we can put 75 kilos of payload on there. We can put full prompter systems on there for studio applications, or any accessories that are necessary. Okay. Talking of box lenses, there is one. So the AFC is our most commonly used head. It typically works with a box camera, and it's sort of a 25 times lens. However, you can put a full-size camera on that. And that's being used in a lot of tennis applications to cover the outer courts. It's been used in car racing to do the whip pan moves, automate the moves, following cars around corners, where you can't put a human next to the track. So this has also got a safety aspect, where you can't physically put somebody that can operate the camera from that location. The cameras are very small footprint, and they just offer that motion. And this is a camera that will do 180 degrees a second. So it really, whips around and gets that lovely shot, and it gets it consistently. You can automate that with the timing barriers, for example. If you know that a car comes to a certain point of the track, you have a light barrier there. As soon as the car hits that, the camera starts moving, and you've got the same shot day in, day out. And clients like Gravity Media are using this with Formula E. There'll be a Goodwood Festival of Speed in a couple of weeks. Anybody going to be there? It's a good show. Yeah. And then we have the big box lens, which is obviously, I'm going to tell you a little bit about that now. Anybody recognize this color scheme? It's not as famous as the green at Wimbledon, but it's the purple of Queens. So we have developed a solution together with Gravity Media in this case to allow them to take the operator that's typically right behind the sidelines, kept getting the ball speed, following the ball, to automate that, because they're reducing the footprint, or they're increasing the seating capacity in the stadiums, reducing the footprint where you can put a camera. So in this case, the camera is right behind the barrier here. Actually, this is a little video that should be played. So we have the operator who is here. It's a bit washed out, but operator is there with the pan bar so he can see the field of play, and the camera is down here moving and following that piece of space. So they get them when they serve, get the hit, they come out wide and follow the ball, and we can all do that remotely from the side of the pitch using IP control. So with a bit of more work, we could actually take that operator, put him in the control room, put him somewhere where he can sit down and do that same job. I mean, in tennis, you don't work when it's raining. They've never heard of rain covers, apparently. But it's a good application, and it works really, really well. Whipping around that, 45 kilo weight using those robotic heads. And as I said, all of this can be done remotely. It's all based on IP, which is allowing you to, with a good connection, operate cameras all over the world, as I said earlier, from in any location. All right. So one of the coolest things I've ever done, I think, is using these big studio robots. I used to work in operations, so carrying around these big robots and installing them. Never really operated them, and then during COVID, things changed. We had to do virtual productions. We were covering live studio sessions for a rather well-known corporate that was doing their PowerPoint presentations in a virtual production studio with LED volume and set extensions. And I arrived that morning setting up the robot when we got a call to say that the operator, who was doing manual shots based on what the director was doing, couldn't make it. He had COVID. So I had never operated, but I was the only one there that wasn't already assigned a responsibility in the afternoon. So I had to sit down and learn how to operate this big robot, 6-axis, camera control, live motion on air with a graphics system, director in one ear, watching the TX and watching when I'm on tally, and all this really complicated stuff. Sat down, had an hour play with it, 2 joysticks, and I was able to do the whole show. So what I'm trying to say is, it's really easy to use and operate, and actually really fast to get a hold of somebody who can operate them. And if you really wanted to, you can use an Xbox controller. So some of us from the younger generation have that muscle memory from Call of Duty, following people around. So that works as well. And we can do lots of different types of let me rephrase that. We can do lots of control mechanisms for the same camera. So all of our systems are designed for studios, which means they are quiet, they are smooth, all the motion is on-air worthy, so you can go effectively do a cutless show if you really wanted to with these systems, meaning the robot can give you the 1 shot on your presenter. If you then go to a 2-shot, comes out wide, and all that can be done in such a way that it can actually be done on air. With the transitions, all the starting of the motions when the motors engage, all of that is super smooth and silky to make sure that it's completely and utterly seamless. And it integrates with all graphic systems from VizRT, Brainstorm, Zero Density, Disguise, and really, and also Unreal Engine and all things like that. Yep. And really cool, actually, there's a studio in Germany that we've installed a robot in the ceiling. So this is on about 15 meters of track, and it's an entire 2110 IP studio. They don't even have a switcher. So it's all done over IP, using VizRT's Mozart for the feed selection. Every feed comes in effectively as a graphic, and each the rundown is pre-programmed from Mozart and the automation software, that it basically says if we're going to this part in the rundown, the robot has to move automatically. So as you're starting with the intro shot, it comes in from the back of the stage, goes in tight on the presenter, who then starts with the intro. Then they go to the first segment where they know they have a graphic coming in on the right. Robot just moves back a little bit, zooms out, gets the presenter, and does all this fully automated. Obviously, it takes a bit of time to set up, but it can be done. So this is a studio that does 3 shows in the afternoon. And they go from the news show to the financial update and then the weather bulletin. And they do this with 3 staff, switching everything, the full production. And this was the only way they could build a studio with their budget. All right. So now, robotics in a traditional sense have been used to solve problems that are impossible for humans to do. Lifting heavy weights. You know, a forklift effectively is a remote controlled robotic system because you're controlling motors. Following planes with a camera, things like that are very hard to do, like I mentioned earlier, are cool. However, when you then look at that, it enables something else that is almost impossible for us mere mortals to do. When I say this, we call it virtual teleportation. And I think this is the most exciting innovation that we've brought out recently. Basically, it allows us to bring people in from a green screen studio that's in one location, let's say London. So they're in a green screen studio, and we're here in Manchester in our real set, but you want to bring them into the studio to talk as if you're really there. How do you do this? I'm not saying you should fake to people that people are in the same room when they're not. Do say so. However, we use green screen. So we bring them in, take the feed, key it out, and place them next to them in the studio. That's all been done before. What hasn't been done, and what I think is the innovation here, is adding motion using robotics. Because we can control over distance, we have the 2 same robotic heads in both locations, meaning that when the one in the studio moves, i.e. it goes from a single shot to a 2 shot, it comes wide, the robotic head in London does the same thing at the same time. And we can compensate for the delay in network connection. And so when you then come out, you do your wide shot, your 2 shot, you have the same motion occurring on both sides, meaning the effect is maintained that both people are in the same studio together. And this is being rolled out with major broadcasters at the end of this year, and basically allowing them to bring the presenter that stayed in London because they didn't want to travel, or for environmental reasons, or COVID, or whichever reason, isn't in the US Open. They would still want to talk to Rory McIlroy as if he's really there. We can bring them together in that way. And because you can set this up in such a way that the eye lines are maintained, there's a preview monitor in both locations. It does actually look like they're looking at each other because they actually are. And then we're just combining the feed together from a virtual production perspective. I didn't mean to bring a video of that, but that's not in this presentation for some reason. Let me have a look. Yeah, but in the top right picture here, you can see Gilbert, and then me in the green screen on the left, and then we've keyed them together. So, but please do contact me afterwards to get a bit more information on that. Delivery, how does it change what a studio is doing at the moment? It doesn't. That's the beauty. It integrates really seamlessly with most systems. All you're doing is adding a little bit more space in there. So, we are camera agnostic. You can use your same cameras that you have at the moment. It's IP based. We route SDI through the arm. You can use SMPTE cables. All of those things are not affected. All we're basically doing is replacing a tripod. And so from a delivery perspective, these are really, really easy to implement in a studio. We can ceiling mount them. There's a big trend for safety, trip hazards with rails, with cables, etc. A lot of studios want to have that look as if they're, super slick. I think the robots look pretty cool. They're pretty slick. So we'll tick that off. Safety aspect is maintained. We also have light barriers or laser systems that do detection of people in the space. So that means that if anybody approaches the robot when they shouldn't be and it's moving or it's about to move, it will shut down to make sure that safety is maintained. And will do so either on an emergency basis or if there's a bit more space, come to a slow stop, stay there, until the person has left that space. So, as I said, it's open integration. The payload determines the size of the robot that you need. It's expandable, so all of our systems work together. You can control multiple heads from one operating system, so you can have up to 12 robots working in a studio seamlessly together, all enabled with AR. I think that's the main points of that slide. Good. And then on the lower end of the scale, where you are maybe starting out, you're a small production house, you're doing commercials, etc., we do offer also the smaller rail systems, for example, that are automated. You can take these on your bees. They are completely handballable, so that means all the operations, all the screws, all the fittings can all be operated by hand, so you don't need any tools. Allowing you to add, if you're coming outside and you're doing a little shot or interview outside, you can put this on a tripod, move back and forth, either manually or through a loop, and it just repositions. So when you're doing your presenter shot, you get that lovely parallax in the background. And I think that's where the real value is for simple things like that. You're not taking anybody away, you're not adding anybody, you're just adding a little bit of lateral motion to your production, giving you more of the scene in the background, and allowing just for that picture to be much more beautiful when it goes to air. And that can be expanded to bigger robotic heads. It's heavy duty, it's rugged. Some of the stuff you can probably drop it from this height and you have to repair the concrete. So it's manufactured out of real good stuff. With a variety of control systems, which can also be done wirelessly, so that you have that ability to adapt to any situation that you find yourself in. And then we have a very, very powerful software tool. And that's really where the key is. The hardware itself is fixed in space or in time. When you get it, the hardware doesn't change unless we come and make changes. However, the software is what gets better over time. It's the same way, your Tesla car suddenly has better performance because they found a magic update to the software of how the motors are driven. Well, for us, it's the same. So as people are using it, we get more and more feedback. One studio would like a feature. We add that to the software, and then at some point later, everybody has that same feature. So you're always up to date. Your capabilities increase over time. With the service agreement, those things roll out to all of our customers, as new features are being developed. And I think that's the really cool thing. As our install base grows, what our customers are doing increases in creativity, and that pushes the boundary of live production and studio productions for everybody. Any questions? Perfect. The test will come, is on your seat, so if you fill that out. No, just kidding. All right, so that's MRMC, camera robotics for live and OB applications, for sports, for small studios, for corporate environments, house of worship, PTZ enablement. That's the other thing. You can use a PTZ camera on most of our equipment. So we really have that, and you just want to add a little bit of that back and forth, or forward and backwards, or up and down motion, we can do that. Cool. Thank you for your time.